I've said enough. Thank you for being here.
My pleasure.
And this is Fifth Career Game Design.
Excellent. Well, thank you for having me. I'm gonna start off with sort of a brief overview of how I began programming and how I got to where I am today via the projects I've worked on. My thing behind this is there were a lot of questions in both class periods about, how'd you start? How are you moving forward? What was your experience? And I actually wish I'd had someone I could have asked that question to when I started. So I began my programming career at a place called the Gazelle Neuroscape Research Facility. It's associated with the University of California, San Francisco. It's on the medical campus, but is in fact a private research facility. So a big focus of the facility is to research ways to use everyday technologies to improve human life, health, and behavior. So the two primary projects I was involved with were the Body Brain Trainer project and the Glass Brain project. Now, the Body Brain Trainer project was the first actual piece of software I ever worked on. I had not previously worked on my own software before that point. So it was a little intimidating to start off. I had a team of 2 other people, one of whom was not a programmer, but just a 3D modeler. And we were supposed to be creating this enormous brain-altering piece of software. So to start with that, they had me just doing little things like, okay, make this character move from this position to this position so you know how the transform component works. Add and remove components via code instead of via the inspector, things like that. Very basic, but it still took me time to get acclimated. But they provided that, which was good. And that moved into when I was given the responsibility to develop a physical input method for the program. Now, I'm not sure if anyone here has worked with the Xbox Kinect. There we go, someone out there. We've got more people. Perfect, okay. So I worked to integrate the Xbox Kinect 2, which was slightly more accurate, to Unity and convert physical movement to the completion of tasks. And so what I would do is say, okay, if the person's walking like this in place, they will move forward, they go faster, we just measure that change in rate. But that presented me with my first real challenge, and that was, how do I go from really basic vector movement and component modification to integrating an entire service that I don't have control over? And that was a challenge. That was definitely a challenge. So in doing that, I wound up taking some free courses from Microsoft Virtual Academy, Code Academy, Solo Learn. You name a place, there was somewhere you could get some information. It's my understanding you guys had previously worked with Solo Learn as well, or similar learning tool. So after that, I sort of reached a point where I thought, okay, this isn't the demon I thought it was. It's not as difficult, and I was actually able to integrate it such that you could move your player around when your player needed to move, and you could complete these standardized neurological enhancement tasks through physical movement. Now, the aim of this project was to determine whether or not working out your muscles and your brain at the same time and in a coordinated fashion would improve the resultant growth of both, which we did show to happen. We also showed it had some sleep effects, so there was also even writing program to monitor people's sleep, which was interesting, but not so much my department. But what we learned was when you have someone complete a task, say, they have to touch 4 rings that lit up in a specific order, when you actually have to, move your body, go like that, reach over here, jump forward and do a push, something like that, it seems very basic, but it actually better cements the cognitive task, and it creates and enhances your muscle memory. So it combines type 1 and type 2 thinking, slow, accurate thinking, fast, resultant thinking. And that actually led me to my second project, because I then developed a reputation for working with peripheral hardware, such as the Xbox Kinect and a Garmin heart rate monitor. So after that, I moved on to the Glass Brain project, and while I was not directly involved with the development of the Glass Brain component, my job was to integrate the first release of the Oculus VR headset as well as something called a leap motion controller. Now, is anyone here familiar with either or both of those items? All right, cool. Okay, so I'll go down this track then. So with that, the program was able to take a 3D scan, a functioning MRI of someone's brain, render that to a 3D model, and calculate by passing signal data through a statistical language called R. And it would live render the recordings of your electrical signals in your brain on the screen. Now, the goal here was to create a diagnostic tool, and something so unintuitive is never going to make it off the ground floor. So my job was to integrate the Oculus and Leap Motion such that a physician, researcher, you name it, could very easily interact with and view this representation of the brain. So what I did was, by mounting the Leap Motion on the front of the Oculus, you would pull your left hand up, and when you went like this, it would pull up a virtual menu that you could then interact with your right hand. You could enable and disable particular parts of the brain, nerve pathways, which electrical signals you want, essentially any component. And the key to this, to bring it back around to what you're learning, is that all of this was done through modifications to the base components of the Unity game engine. There was no fancy proprietary software involved, which was our primary goal with all of these experiments, was at-home technology. We acquired it for free from Unity, and we programmed with it. We essentially made game-like software, and in the case of BBT, actual game software, that would, in theory, enhance your ability to live your life to the fullest. And so that's how I got started. I literally became a volunteer there with 2 hours of experience. So never hurts to ask. It's one thing I cannot stress enough. The worst case is they say no. So moving on from the laboratory setting, I then moved up here to Washington to attend the Evergreen State College just down the road here, because I wanted to study not game development itself, because I had taken about 100 hours worth of classes at that point on game development in Unity, but I wanted to study computer sciences so that I actually understood what I was doing. So my specialty lies in game development, but more specifically in systems development and memory management. That means I am incredibly obsessed with making my things happen very fast. A key example of this will come up shortly when I discuss my project work at Evergreen and how I integrated that with standardized computer science courses. But it may be a little early to introduce some of those concepts, but we'll see. So at Evergreen, a lot of what I learned was how do you manage a project, how do you design your software before typing a single thing, how do you actually know what the minimum requirements are for your product's functionality, which in the game development sense would be the minimum viable product. And that was all very useful in conjunction with the standard computer science curriculum. But it wasn't until I actually integrated all of this into a singular platform and project, and that would be the Cronus Project, which I have up on the screen here. Now, the Cronus Project is essentially your basic, Counter-Strike or Fortnite or whatever kind of game. Very open, very multiplayer. I will note it is still highly incomplete. We're only about 200 development hours into this after about a year and a half of planning, so there's a lot to do. But what's important about it is that while I did not utilize them to the best of my abilities, and I view that as very much a learning moment, I was able to think about not just what I wanted it to do, but how long it would take to get it to do any part of that, and then how long it would take to get to do the whole thing. And so, and I'll get to this a little bit later once I move on to overall organizational topics. Part of how I did this was just, okay, I know that I need to turn in this by this week, this by this week, and this by this week. So if I do these in this period of time by creating, let's say I wanted to focus on the terrain mechanic. A key point of this game is my friend and I thought people, you play the same 3 maps over and over again, you're going to get bored. So every time you click play and you enter a world, that world is created in that instant, within 3.2 seconds. Something that has not existed before is calculated mathematically and generated. Now, the key to this is that I budgeted my time completely incorrectly. I assumed that the primary content of the game, which was instead of that standard one level, you have to manage, spatial attributes, where's my opponent, where's the objective, where's this, where's that. You also have to think about when with the Cronus Project. Each level is subdivided into 6 levels. And those 6 levels each operate at a different point in time. So level 0, and there's no loading between each one. It's actually the same level, and we've come up with a way to programmatically separate players so it gives the appearance of a change in time. So now we have people thinking, okay, if I want to clear that building of opponents so I can get the flag, why don't I go back in time before they were in there, waiting there, and then when they do show up in 5 minutes, I'd take out the enemy team, take the flag, and go home. Players have not caught on to this yet in our testing simulation, but it seems to be a fun concept. But the real issue came out when I was trying to design it. I estimated that the time system would take me 8 weeks, and the terrain system would take me no more than 2. The time system took me 2 hours, and the terrain system took me 8 weeks. So that didn't quite work out, but it taught me an important lesson about management, and that is A, communication, and B, quite frankly, it's charting. It's making sure everything's written down, it's organized, and you can review it in a timely and effective way. One example of this is that you can create these functional charts, which I believe you guys have been introduced to at this point. So what you're seeing here, and I apologize for the lack of visual here, it's a little blurry on this screen, but this is the original version of the terrain generator. So this describes every single action that needs to occur in order to have the terrain actually show up and be randomized every time. It even revealed in my planning an additional problem. I never set up time for memory management, which is my primary specialty. I was too focused on the classwork. And so, just as an anecdote, the first time we tried to execute this program, it took an hour to load every single level. Each level was equivalent to an entire hour of computer time. And in terms of future memory management, after adding something, a feature called multi-threading, which is where you break up the program into small parts and let all the CPU cores do their work separately. It brought the execution time of this system, bless you, from 1 hour down to 3.2 seconds. And so that's definitely something I cannot stress enough going forward, but certainly not something you need to know for the Flappy Bird project. Yes? Yes, everything I work on is in Unity. So given this overly complex chart, what is rendered from that is, well, you have this system, so this is the actual generation sequence, and this is still the same. The code is different, but the sequence is still the same. So you have the what in this case would be the awake function. Have you guys come across the awake function? And you do, yeah, okay. So you have the awake function. That calls this initial generator. And then at the same time, it spits off another thread after the data has been received and says, okay, the same way you're determining the height of the terrain, also assign it a color. That way you can tell, oh, that's supposed to be a snowy mountain. Oh, that's supposed to be, a lake. You don't want everything being just drab. And that's a key point in game development as well. For minimum viability, while you don't need anything too flashy, it is often useful just to give something a basic color, red, green, blue, just so you can differentiate objects and do some visual debugging. So it keeps going, and what it does is once everything has been loaded and inserted in chunks, it simply just turns everything on and off from there. Object pooling, which is also in the Flappy Bird tutorial. Object pooling is another programmatic pattern that I cannot understate the value of. I've had entire projects, before I knew what object pooling was, be brought down by the memory issues introduced by instantiating and destroying objects constantly. And so, after about 200 hours of work, we got that. Each time, like I said, that this shows up, it's completely randomly generated. So the chances of you playing the same level twice, if I recall correctly, is something like 1 in 10,000 or, no, 1 in 100,000, something closer to that. So it keeps the replayability, although my professor did make a note during my presentation to the class that why can't you save a level? What if you want to play it again? It's always something to consider, and it brings to mind another point about organizational work for developing a program, and that's what I call the B list. So the B list, if we go over here, I'm sure you guys are now familiar with Trello. So if we go to the B list, which I have right here, the B list represents features that I would like and just I need to focus on something else, or it's something I've found the capacity for. I'm not necessarily going to put it into the program, but it would be cool to have it in there. Or even, okay, we haven't been able to fix this issue. Let's create a workaround, put the issue as a sticker in the B list there, and then when we have time, we'll come back to it and solve the problem. It may even be stemming from somewhere else, so there's no real reason to put all our effort into one basket, as it were. On top of this, I find Trello to be a particularly useful resource when it comes to personal projects, especially ones where I'm working on recreating something. So right now, there's this mobile game called SimCity Build It. And you can, I think I see some nods out there, but you can play it competitively with a club. And my friends were saying, it'd be great if we could think out our strategies ahead of time, but, the timers aren't always the way we need them to be. We can't, think this all through. So I thought, well, I'm already well aware of how the mechanics in that work. So why don't I just reprogram it from scratch? It'll be a good exercise for me. It shows me some potentially new things. I personally have not come across a project where I haven't learned something new that was very valuable to me later on. And so I started working on this project actually on Monday. And what that resulted in when I first designed the Trello for it is a more coherent organizational system. So since I know what goes into all of this, I could easily think of, okay, I need this group of functions. I need to be able to place houses and roads. Those were the first two steps. The roads still aren't working, but the houses do. So what I did here was say, okay, given that I have a UI and I have a placement system, I need to integrate those two things. So I made two cards on my Trello here. One of them is the placement system, and one of them is the placeable UI system. And you'll note there's a third, which is actually road placement system, which and that the key there, and that would ordinarily make B list, but I didn't have enough features that I was worried about the timing. The key there is that I could have made that a single task, a checkbox task, in either of these two cards, probably the placement system at the top there. But because it was so much more complicated, I actually had to sit there and think out, okay, what are my potential avenues of development? What is it that I would need to do in order to get this to work with the already existing placement system and therefore the input system, which you're probably familiar with how some of the input material works from the Flappy Bird tutorial. Key example that the input.getMouseButtonDown 0 is not the equivalent to double tap, things like that. So a lot of this stuff is translatable. The real issue I came across was that the UI is not the same interaction type as input.getTouch or input.getMouseButton, things like that. And so when I was setting up the road system, I had to move it into its own card because it's by nature not the same touch system as the original placement for buildings, for factories, etc. And that's a key point, is you need to be able to differentiate when to go from, okay, it's just a data point, to it's an entirely separate task when you're designing your product. And that feeds back into, and I was talking to Scott about this earlier, MVP, minimum viable product. So I have this organizational strategy, but this doesn't tell me what my minimum viable product is. It tells me what the functionality of my minimum viable product is. So going back and thinking about that, I was considering, okay, if I want this to basically replicate a game but be faster, what does it need to do to get there? And what does it need to feel like to get there? And that is a key defining point of a good program. You can have the best functionality in the world, but if it doesn't feel intuitive to the user, it's not aesthetically pleasing to the user, they're not going to use it. And that has probably killed 2 or 3 of my projects. I cannot stress enough how important it is to take time near the end, not at the beginning by any stretch. You go with the 20-80 model where the 80% is just all polish. And when you come to the end, then you can put in things like a highly usable UI, user interface. You can look at creating maps for user experience decision making, decision trees, things like that. Those come in at the end, and those will make or break a project regardless of how effective it is. And so that's sort of a basic overview of my origins and organizational strategy. So I want to try and move on to some of the questions I was getting, and a lot of them had to do with actually using Unity itself. So Unity is inherently designed such that anyone can download and open it and just start programming into it. You can do this, that, the other thing. You can go through the example projects. You can look at the sample assets. It's definitely designed for a more open crowd. It's not like you have to download this for the animator and these packages for the non-player character programmer. There are a lot more options than it first appears. So a big thing is familiarizing yourself with the Hotkey System. And that is most windows are accessible with 2 button presses. So a common one was the animation and animator windows. And while the animator window does not have a hotkey assigned to it, if you were to push on these Mac computers Command 6 with Unity open, it would just throw the animation window onto your Unity page. And then you can dock it. So a question came up, how do I organize my Unity layout? And I thought that was a very pertinent question because it's actually very important to your workflow. So you guys will have or do have the documents on the server?
Yes.
Yes. Okay. So if you go into there, I believe it's actually period 5 where I included the screenshot. But I put a screenshot of my layout. I tend to prefer keeping scene, game, hierarchy, project, inspector windows, and debug window. And the reason for that is instead of having to rely on the very small camera preview window for when I'm actually trying to see what's going on, or having to rely on some other minor system that doesn't really give me the best picture of what I'm trying to do, I can always look between, okay, this is what Unity is reporting, and this is what the user should be experiencing. And that is very important, because if you aren't, while I did say that you had to, leave the user interface stuff to the end, all that, it is important to monitor how things feel when you use them. For example, back on the City Builder project, when I sent out the first test to my friends, they said, it's great, but building placement makes absolutely no sense. I take my finger off of it, and I thought it was placed, and then a button showed up somewhere, and I didn't know what that button was, and I tapped that, and then it moved the building. And I said, okay, you have a fair point. And so that's the kind of thing you need to consider the entire time is how is it that the user interacts? It's not my field of expertise. I'm more of a systems developer. But even in systems, you have to take these things into consideration because at some point there will be an end user touching that system, so to speak. And if they're touching it and they're not liking it, again, your project is dead. And like I said, that's happened to me several times. So that's sort of the basics there. I wanted to touch as well on the Flappy Bird tutorial itself. Just a few notes that I wrote, and those are also available on the server.
You do Command Tab.
Yep. And
I have it open right now.
thank you.
So that's fifth period on the left and third period on the right.
Perfect. And then I just need to find the so this is one of the things. So organizational tools will get you far. They will. And I'm sure everyone would agree on that front. But there's one thing that I have to say has been a lifesaver. And again, sorry about the blurriness. But this is my set of notes. So these are the things that didn't go into my organizational strategy. They're things like commentary on, why did they go down this? Thank you. Why did they go down this route? Why, what major changes to the system did I make? Things like that. So in this case, we'll just start with the adding sprites video. All of these are organized by the title of the video they were developed on. And so I thought it was important. So first, we learned how to do confirmation of import settings. And that was pretty simple. But it was imperative that I knew how to do that because I had to do it 4 times. So that made it into the notebook. But then you start going down here, you'll see, okay, there's a whole bunch for editing the bird sprite, but not a whole lot for anything after that. And in fact, grass thin does not even have a number before it. So for me, like my color labeling system in Trello that I mentioned, I will differentiate between the level of importance of a given task. So if I've done it a few times, but there's a slight modification to it for a different sprite like grass thin where we didn't have to go through and run the editor on it, I'll generally I'll still put the note there, but I will only put the difference as a subnote because I don't think I need to rewrite the entire procedure. Now, sometimes that's important because that little change can, send you down a completely different set of decisions that you have to make. But short of that, you can keep it pretty short, concise, simple. And then another thing that I think is, wow, that went way down the page. Well, if I can get to it. There we go. Yeah. So there's 2 things on this page that are very important. One is the performed test play mode passed comment. Every single time I make a mass change to a system, in this case, I think it was just adding components, rigid body 2D, box collider, no, it was the polygon collider 2D in this case. Those kinds of changes, while they may not seem major, it's very easy to miss a step when it comes to something like setting up an object to work with your physics engine. And in Unity, compared to some other things I've noticed, it's even easier than normal. There's a lot of options. So every time I make one of these mass changes, I will perform a test and make a note of it, and if it passed. If it doesn't pass, I will then make additional notes about hypotheses and potential solutions. So break down, okay, what is the problem I'm seeing? What behavior am I getting from the game engine? What behavior am I getting from the player window? And what's the difference between the two? What potential code or component assets are causing this to happen? And it's that differential comparison that really has been the cornerstone of my problem-solving method. Because there's a lot of ways you can tackle it. I mean, after that, I'll also consider, okay, this option has these pros and these cons, basic pro-con comparison. But it's that difference calculation, is this similar or is it more different or, name some kind of difference between A and B. It's important to note these things because it's generally going to be very indicative of what kind of error you're getting in the first place, even if one's not showing up in the debug window. There was a relatively recent case where I was working with someone, Jay Balakrishnan, on his main project, and I had this great animator code set up, but every time I click play, nothing would happen. Just completely dead. No animations, nothing. And I thought, well, that can't be right. I'm not even getting an error in the debug window. Whatever. And I realized it's not about the code. The code was fine. I never set up the animation states in my code. I never dragged and dropped them into the public slots. And therefore, it was calling something that didn't exist, but it wasn't giving me a null reference error. And so that's the kind of thing I'm talking about. There would have been no alternative way for me to actually assess that situation through some sort of script debugging platform. That was very much a problem with I just didn't do all the steps. Note that I did actually make sure all the public assignments are made before testing the program as a task, and I did not do it. So also make sure you reread your tasks. So after that, so this is where things get more important for me in terms of the learning, because 5 years in, I still, like I said, there's not a project that's gone by where I haven't learned something. So I like to, at the very start of a new section, say it's a new system. I know I said these are based on the videos, so just imagine for a moment you're basing it on the placement system from the City Builder project. Well, I want to go into it knowing, okay, what are the core concepts I'm using at the most fundamental level? I mean, I don't want to talk about the exact concepts I'm using to implement that system, but what's the scope of the system? What do the variables need to be? How many of them need to be constantly alive for the class? These are all things you may not encounter them so much now, but certainly will later on if you choose to continue down this route. So I noted that based on my understanding of the Bird script, it had multiple class scope variables, which meant those had to stay alive and initialized throughout the entire execution of a level. It used a Boolean value to control death, which is really just what one would call a game logic control structure. It needed to access events using Unity functions, which in this case was onCollisionEnter2D, which is a function I've often been surprised to see in 3D games. And then it also introduced Monobehaviour Functionality. And monobehavior is a great thing if you understand it, and is terrifying if you don't, or it can be. So all that really means is that when your script is running, it is called upon by the game engine itself. So it has access to a few internal variables. You can retrieve certain types of data if you have that as an inherited class, but you cannot do those things without it. Which I actually learned during an experiment on this tutorial while writing these notes. I thought, well, why don't they just have that script in a non-monobehavior class so that you just manage the memory yourself, make it more efficient, just bypass the whole thing. Can't check for collisions without it. You can't even assign it to a game object. You can't drag and drop your script onto your bird if it's not a monobehavior inheriting script. So that was something that was important to know. Now, moving on, I'll also make additional notes if I'm doing something, and especially if it's a tutorial, I like to challenge myself to think, okay, what would I have done differently? And in this case, there was one. Sometimes my notes are just, oh, well, interesting that they went this route, or I went this way, or this ended up working when that didn't. But I like to do things like could have introduced require component flag. That, in this case, would have, because when I was reading questions about animator issues, they were the same issues I had on Mr. Balakrishnan's project. And so I thought, well, what happens if I just throw requirement type of animator at the top of my script? Well, it will automatically attach an animator controller to my object. And the reason this was important is when you add a blank animator controller, you do get the null reference errors because you aren't referencing anything. You're referencing an empty object. And so that was just something I thought, The guy, he did a great job, but he could have brought that up and said, okay, if it's not on there, throw an error, shut down the level. There were a bunch of ways we could have gone with that, but nonetheless, his method was perfectly effective. I also noted that this was a good introduction to physics programming using multiple types of collider, as well as introducing the rigid body 2D. I thought that was, he did a very concise and yet still verbose explanation. And then I said it was a decent explanation of when to use a coroutine. It was. I will note that I slightly disagree with him. He's right about this particular instance, but I find coroutines to be extraordinarily useful for timed functions, and actually use them for the project with Jay. The entire thing is based off of a series of two parallel coroutines that are constantly performing timed functions. And so I also noted that there were a lot of questions about animation in general. So I know I briefly talked about hot controls and all that, but generally speaking, if you're working with some component or system component in Unity, if you go to the window button at the top of the dialog bar, or I don't know what that is in non-programmatic terms, but there's that bar with file, edit, view, etc. If you go up there, there's a tab called Windows, and if you go in there, it actually it used to be really convoluted, but they started breaking it down by which engine system you're working with, and so you go Window, Animation, Animator, because that, like I said, doesn't have a hotkey. But it's important, just to go over these over and over again, make sure they get habitualized, like, okay, I need to go over here. And that's also part of why I keep my layout like I do, is I can think of it in 4 chunks, more or less, and that actually plays back to what I did at the lab and System 1 slow thinking, which you can generally hold about 4 chunks of data in your brain at a time. So breaking up my window into 4 quadrants allows me to memorize where everything is more easily. Does anyone have any questions so far? Nope? Okay. So there was this, yes. When working with Unity or coding in general, what is the best course of action to take when something just won't work? Be listed. If you can, be listed. In my experience, it's better to come in with 98% operation and something slightly missing or not acting as it should than it is to come in with 50% of your product because you spent the entire time trying to fix one thing. And believe me, I have made this mistake way too many times. So you can be-list it, but if it's something that's actually a fundamental component of your software, the best course of action at that point, I would say, would be to try and reach out on, say, like Stack Overflow, if you guys are familiar with that website. Yeah, I see some nods out there. Yeah. I'm 5.5 years in, and I use that website all the time. Sometimes there's just something that's not making sense. And sometimes that might actually even be Unity itself that's causing that problem because there's some glitch there. Someone on there will definitely have run into this before. If not, Unity Help forums. If it's a glitch with Unity, it's on Unity Help. And they usually, this is one of my favorite parts about the community, they usually provide a log of how they fixed the problem or circumvented it. So there was a time, and I guarantee you this will happen. So this was last week. My friend and I were trying to come up with this text-to-speech system for Project Projector with Jay. And they discontinued part of the wrapper, and we couldn't get it into Unity. Well, we go online. We find it on Stack Exchange. Someone said, oh, this guy wrote this new, handwritten DLL for that particular text-to-speech system designed to work with Unity. Because Unity probably B-listed the problem. And so we went on there, we took his code, followed his instructions on how to compile the new DLL, put it in Unity, worked the first time. And that was just, it's a perfect example of it's critical, we can't ignore it, so how do we maximize our use of resources in order to accomplish this in a reasonable amount of time? And believe me, as much as I hate to admit it, there have been a lot of times where something just hasn't worked. But I am happy to say there's almost always a simple solution, or at least some manageable solution that'll work for the time being. Covered that. In terms of, I also saw some questions about 2D layering. 2D layering is the system by which Unity can differentiate between objects. This one's actually, it's not as talked about as you might think. So I'm not surprised it's come up. I actually didn't know about it until about a year ago, when I just happened to change the number by accident, thinking I was clicking a different box, and it solved my overlap error with my far background and mid background. So in this case, yeah, you can go to the sprite renderer component of any sprite, and it's going to have an option for a sorting layer, and it's going to have ordering layer. And so, you know, for, let's say you had far background, near background, and they're overlapping. Well, you would create sorting layers far and near. And then if you had multiple objects contained on those layers, in order to prevent them from overlapping, you just assign them an order in the layer, order in layer. And he explained it in the video, but just to recap, the way it works is 0, I believe, is the furthest from the camera. So everything you apply above 0 is going to be closer to you than object 0. So that's generally the fix for those kinds of things. I've definitely run into the case where I wouldn't quite call it an overlap, but the way the sprites were designed, they created like an interference pattern when they passed each other, and I still haven't figured that one out. But yeah, overlapping, pretty common stuff. As far as animating quicker, the guy who wrote the tutorial actually did a pretty good job of explaining that. You're going to need keyframes. You're probably going to develop it from a sprite sheet, because why would you create a different asset for each one? That's just going to harm your memory usage. So what you do is you can just make all the sprites in one image, or you can move them all into one file after creating them all separately. I prefer, personally, I'm not a big artist, I'm a programmer, but I'll make all my sprites in the sprite sheet itself, just on different layers in Photoshop, because that way I can reference, oh, well, this one's supposed to be slightly different this way, and I have the other one literally right next to it and can zoom in at a pixel level. So, it's easier. That's different for everybody. Sprite sheets are always the way to go, and sprites are actually the only way to animate in 2D in Unity. So one way or the other, you're going to need to make them, so you might as well make the sprite sheet and just have Unity automatically slice it. Now, this leads to another issue that came up on my City Builder program. If your sprites are different sizes in the sprite sheet, it will not cut them up. Or it will, but they're going to come out different sizes, because it's actually creating a bounding box around the sprite, judging by pixel brightness, more or less. So that's always something to be careful of. You don't want, well, unless you do literally want it, but generally speaking, you wouldn't want the bird hero to jump from one size, then to another, then back. It just looks awkward. People are going to be thrown off by it. There are only a few cases I can think of where that's really necessary. Like if you wanted like a nice breathing dot animation or something, that would be fine. And that would actually be a good way to utilize that small inconsistency in the sprite editor, is just by making different sized dots and then hitting automatic trim. And it will actually create the breathing function for you. But definitely something to be avoided, if possible. Let's see. So are people still having primary difficulty with the animation system? Because a lot of the questions from both classes were very specifically geared towards the animations in the tutorial. So if you guys would like, I'm absolutely happy to cover that. I tried to get my Unity project for the tutorial to open here, but this computer's running 2018.2 and refuses to open it. But definitely something I'd be happy to cover just because that part of the tutorial was a little convoluted, to say the least. It was a little hard to follow. Or other questions. I'm happy to take all the questions. Yeah. Other than that, I mean, I've covered sort of my background. I've covered organizational skills. There's a lot of different ways, and I was reminiscing on this earlier. For each problem, you're going to probably find about 1,000 solutions, and this is something that I didn't genuinely believe. I thought, okay, maybe they mean like 2 or 3. No, if you run into a problem, there's probably about 1,000 ways to fix it in programming. It's remarkable how many people have run across literally the same problem. I mean, I've typed in, how do you write this link query? And I had 19 results on Google that were my exact problem, word for word, with an error message. And I thought that was actually kind of a nice touch. It's like, oh, well, everyone's trying to figure it out. You'd think they would have solved it, but no. So just for a quick demonstration then, so I wrote the project, a couple of weeks ago, and I did find that there were a few things, especially about, like I said, the animator components and animation component that the guy was talking about that didn't work out so well, in my experience. I also modified, I didn't see any questions about this, but it's something that certainly took me by surprise. His approach to handling the box colliders for the pillars here was a little odd. I noticed that when I replicated it precisely, and this is definitely something to watch out for with colliders, that offset, you need to be really careful because it's like the sprite editor. It's going to try and make that bounding box, and it's probably going to give you a little bit of an air gap. And I couldn't, sending this out to people, and they're like, I don't know, I just can't win it. And I thought, seems odd, so I zoomed into the pixel level and watched as the bird went by the colliders, and I noticed colliders are coming above the columns. Of course you can't get past it. You get, mildly close, and it kills your bird. So I did make some modifications like that, which I believe my notes should reflect. If not, that was a mistake on my part. Yeah, so that about sums up what I have here. I was thinking, though, and I talked to Scott a little bit about this. So one thing that's getting really big right now in terms of the hiring world are mobile apps. Everybody wants a mobile app. And in fact, I made one of my large examples my replication of a mobile game used to enhance my competing capacity in my team. So I was thinking to myself, well, what's a good way to demonstrate the skills needed and planning needed to create a mobile app? And the first thing that came to mind was an app I wrote a while ago with sort of a jokey name. Like, there's all these cut out the vowel before the R at the end of a word. So I call it Carter, as in a shopping cart. And what it does is it lets you set a budget. It takes that budget, makes sure it won't let you add new items if you're going to exceed it. It saves that data to a text file in receipt format and also uploads it to a server that I'm now working to make accessible via a website. So it'll, graph out your expenses, chart what you buy. Are you buying healthy enough? Do you need to set a shopping list? Things like that. But the key to this is Unity is not a platform for making these kinds of apps. It is much, much harder. However, for learning purposes, it is still very much the same set of concepts. In fact, it's the ones I've brought up already. You need to have a good feel for how things are actually operate. Is it clumsy when you're trying to type in the new cart item? I'm writing in milk. Is it easy enough for me to access that UI element, type, and then move on to the next one? Well, that very assessment is not something it would pass. And that is why I haven't released it, is because I've not solved this problem. it also goes towards user experience. So how does the user have an overall good, bad, or indifferent experience is one thing. And then it's, did the user actually utilize every function provided to them? Are they only using some, and why is that happening? And that's another thing that's sort of, I wouldn't say invaluable, but highly valuable to those that want to go into the mobile market. Because of the nature of finger input over mouse input, it creates a stronger connection between user and application. And it is certainly a different experience than using an app on your computer. On your computer, I don't care if I'm using Word, I just need to type into it. If I'm trying to type something on my phone, I want my keyboard lined up, I want my autocorrect lined up properly, I want to have the most common utilities right there, more so than I would on a computer. So if you're interested in continuing, I highly recommend getting Unity with the Android and iOS build options and learning how to use Android Studio. And just start with Unity because it's that much harder, and then move on to using the prefabricated utilities for it.
Ladies and gentlemen, we're out of here in about 30, well, we've got about a minute left. I want to show our appreciation for Mr. George being here.